In this video, I'll be talking about a binary search. So in my previous video, I've talked about a linear search. So I've explained how the code works, and tracing also I've explained, and even I've explained about a time complexity as well. So in this video, we will talk about a binary search where the given array is sorted, and I will talk about an algorithm. And if you need the code, I'll put in the description box. You can check it out, and you can copy that code or paste in some code editor and you can check it out. So if you need the code, it will be in a description box. Please check it. And now I'll explain the algorithm part, like how the code works and what is the logic we need to write. Only that part I'll concentrate on it, and I will just at the last I will tell how is the time complexity. So now, so here the binary search is given. So we have to find a binary search. What does a binary search means? So they will be given an array. So one key value will be there. For example, the key value, what is the value that we need to find means, for example, if you want to find the value that is 18, we need to find in this array. So through the binary search, you need to find. So if the array is sorted, you can go for a binary search. If the array is not sorted, like unsorted, you can better go for a linear search. Since the given array is in a sorted way and you have to find the key value as an 18, what you need to do means you have to take a 2 pointers now. First one is low. You will assign, one second, for a minute, I'll just write down here. So key value, what is the key value you need to find? The key value is 18 you need to find. So now we shall take a 2 pointers. One is pointing to 0 index, one is low, another one is high. Okay, these 2 pointers are pointing to the index, not to the array value. It is pointing to the index. So now, as we know that now what in this binary search, basically if you go to this logic part, this low and high, what we are doing in order to find the mid value, what we are doing means we are adding this both and we are dividing it by 2. Means now how do you find the mid value? Mid value is equal to, what is a low? 0 plus high is 9 by 2. It is nothing but 9 by 2 is nothing but it's a 4. Okay. So now the mid value is pointing to the 4th index. Okay, the mid value is right now here. So now we key value is 18. So now if we come inside this, now we will check if this part we are concentrating right now. So if key, what is the key now? Key 18. Is it equal to array of mid? Array of mid value what? Array of 4. It is array of 4 is what? Array of 4 is nothing but 12. Is 18 is equal to 12? No. It will come out. It will check with the else if condition. If key value is less than array of mid, what is the key value? 18. Is 18 less than array of mid? What is array of mid? Is 12. Is it less? No, false. It comes out. It comes with the checks with else condition. What it does means now, low is equal to mid plus 1. What is now mid? It is 4. So 4 plus 1 is nothing but 5. So the 5 is assigned to low now. And what happens? High is equal to, the high value will be 9 itself. Okay. So now what happens? Now where does and low comes? So the low is in, right now the low is in the 5th index. So whenever the key value is greater than the array of mid, what you have to do? You have to add the mid value to the low. Means now what happens? Now what happens where the low value comes? Now the low value comes to this position. Okay. Is it clear? Now again we'll come back. Again we'll come back and we'll check. Yeah. Is low less than or equal to high? Which is, what is a low value right now? Low is 5. Is 5 less than or equal to 9? Yes, it's true. It comes here. Now the mid value. What happens now the mid value? Let's see. The mid value will become, now what happens the mid value? Low plus high. That is 5 plus 9 by 2. What is a 5 plus 9? It's become 7. So then now the mid value is at the 7th index. Okay. Now we will check. Now what happens? The mid value is at the 7th index. Now the mid value is here right now. Okay. Now again we'll come inside. If key, what is the key? is 18 is equal to array of mid. What is array of mid? Array of 7 is 18. Is 18 equal to 18? Yes, it's true. You will return the mid value. You will return, what you will return? Return 18. That is, you will return the mid value. So the key is found, you will return it. Okay. So I think I have explained you how does this binary search work. So I'll explain you if there is a condition, if while loop, for example, see, for a minute, see if if while loop, for example, if low is less than or equal to high, means always you should keep in your mind low should always be less than or equal to the high value. Okay, for example, if the low value is 9 and the high value is 8, if this condition false, means if the key value is, for example, if the key value is 21, 21 is not there in this array. But what happens when the low value is 9 and the high value is 8, means the condition is not satisfying here. The low is 9, is 9 less than or equal to 8? No, false. So now what happens? It comes out of this while loop. It comes out of this while loop, and what happens? You will return -1. Okay. So the key is not found in this the given array. What happens is that at the time you will return -1. So always we should keep in our mind low should always be less than or equal to high. Either it should be equal, either it should be less than the high value. I hope the binary search is clear. So now let us discuss about the time complexity. Very important, that is a time complexity. So as I told you, now for example, if the mid value, so let me just erase this part. Yeah, let me write it down. For example, if the so this is a low value and this is an high value. Okay, so this is a mid value. So if the mid value, for example, if you want to find the key value, that is 12. So what happens in the time complexity, when we divide this, means 0 plus 9 by 2, the mid value is 4. So at the beginning position only you will find the mid, means the given key value is equal to array of mid. At the beginning only you have found the key value. At the time, what is the best case? Means big O of 1. Okay. In the worst and the average case, when you divide an array into our two parts, like the right part you go on search and the left part you go on search, what happens at the time in the worst and an average case? The worst case you get it as big O of log n. So this is a time complexity. The best case, when you find it, if the key value is equal to array of mid, the best time complexity is big O of 1. When you divide an array, like you search if the key value is less than array of mid, what you do, you search in the left part of it, or if it's greater than, what you do is you go for the right part of it. So at that time, the time complexity big O of log n. So thanks for watching. If you like this video, please do like, share and subscribe, and the code will be in the description box.